Hello, everyone. My name is Kevin Tarr. I am an iOS engineer, and today is day 27 of Algorithms in Swift. I can't believe we made it this far, but we're here now. So today we're going to be continuing on with linked lists. We're going to keep focusing on some fundamentals of computer science and some low-level collection types, and we're going to be extending our linked list to try to find the coveted middle node, middle node, the center node of the linked list. Okay, so we're going to be in the same way I was talking about big O notation and complexity with finding the middle node. You're going to see some of that complexity in some of the logic that we do and introduce today. So I'm excited. So let's begin. So our problem states extend your linked list class with a new method that returns the node at the midpoint of the linked list using no more than one loop. And then we have some context here. If the linked list contains an even number of items, returning the one before or the one after the center is acceptable. Great. Okay. So we're going to be extending our linked list class that we worked on yesterday. You see these two classes here. We see the entire alphabet and a problem that we worked on yesterday. To find the middle node. Now, as I was saying in the video yesterday, finding the middle node of a linked list is more complex time-wise. It is order n complexity because in order to find the middle of the linked list, you have to go through each and every single node and get its reference to the next node and to the next node to the next node until you find the middle node. Okay, so that's not as time efficient as we need to be, but we're going to try to create a very time efficient way to do this. We're going to be using two linkers to get to the middle of the linked list. And what we're going to do is we're going to have one node, one linker go through the linked list one node at a time, and the second linker go through the list two nodes at a time. And we're going to be constantly checking if the second linker is at the end of the linked list. And once it reaches the end of the linked list, because it's going by two, and because the other node is going by one, or the other linker is going by one, the first linker is going to be at the middle of the linked list by the time the second linker gets to the end of the linked list, because it's going by two, it's going by one. So we're going to create that function, and you'd be surprised how little bit of logic we have to create in order to make that happen. Okay, so let's begin. We're going to call this middle node. We're going to make this a linked list node, generic. Then we're going to create single speed node, and we're gonna assign that to start node. I'm gonna call this double speed node. Assign that to start node as well. So we're assigning both those variables to the beginning node. Then we're just going to create a while loop while double speed node is not equal to nil, and double speed dot next pointer is not equal to nil. Single speed node equals single speed node dot next, and double speed node equals double speed node dot next. So it's going twice. Okay, and then we're just going to return the single speed node. Okay, so basically what this is doing is constantly checking whether the double speed node is nil or whether the next pointer pointer after it is nil. And if none of those are nil, then it's going to move the single speed node up 1 point. It's going to move the double speed up 2 points, or it's going to move it 2 nodes, advance it 2 nodes within the linked list. And the minute we find either the double speed node to be nil or the next point to be nil, that means that we're at the end of the linked list, or we've already ended the linked list. Us finding the next pointer to be nil means that that we're at the end of the linked list, And us finding the double speed node, the double speed node to be nil means that we've arrived officially at the linked list. And that means we return the single speed node because single speed node should be at the middle of the linked list. Okay, so let's test that with our alphabet algorithm we created yesterday. Okay, so we're going to print the middle of the node. We already have the computed value here, so let's print middle node. And if we're correct, it should print out either M or N of this alphabet once it goes through this whole for loop. We're going to do the print of nodes function, and it should print out M or N. That's our middle node. Oh, sorry. I did it in a while loop. Let me do it outside of while loop. Oh, let me get the value too. That value. Okay. Sorry. Okay. A little bit of some issues, but we have the N here. Okay. So N is our middle node. Okay. I let the while loop spin too many times, but we have N here as our middle node, and that is the 14th letter of the alphabet. So that's the middle node, and that meets our qualifications for our problem. So, guys, this should work, and you will certainly, most certainly, probably be asked this question in the interview. So make sure you understand this. This is a quick and efficient, um, a clever way to get to the middle node and make it time efficient because you're going twice the speed of a basic fast enumeration iteration. So I think this works, and this is a valid solution to our problem. Let me know what you guys think about this solution in the comments, and if you have any proposed solutions to this problem, please comment below. Thanks again, guys, for watching. Have a good night.